In the grand tapestry of the universe, humans find themselves at a peculiar intersection of scale. While astronomers ponder the cosmos, where time is measured in centuries and distance in light years. Nobel Prizes in physics and chemistry recently reminded us of the minuscule world of nanophysics and quantum mechanics. This year's Nobel Prize in Physics honored 3 scientists who harnessed the power of incredibly short laser bursts, measuring just 1/millionth of 1/trillionth of a second. These bursts are fast enough to track the movement of electrons during chemical reactions. The subsequent Nobel Prize in Chemistry celebrated researchers who mastered the assembly of atoms into quantum dots, subatomic clusters so small they challenge conventional notions of dimension. These awards highlight how divorced our human perspective is from the scales at which fundamental processes in nature occur. While the cosmos operates on grand time scales and immense distances, the realm of the very small atoms, molecules, and quantum phenomena functions at a bewilderingly rapid pace and on minuscule dimensions. Carl Zimmer aptly points out that there are a billion atoms in the human body, packed into 37 trillion cells. Chemical reactions within these cells happen in attoseconds, potentially totaling 1,000,000 trillion reactions per second in a single individual. This staggering scale discrepancy between cosmic and quantum processes may seem overwhelming, but it prompts intriguing questions. How do we exist and persist in a world characterized by quantum uncertainty, where particles can exist in multiple states simultaneously? The answer may lie in the sheer astronomical numbers that constitute our existence. The countless atoms and molecular interactions may provide stability and resilience against quantum fluctuations. We are a cosmic bulwark against quantum uncertainty. It's a reminder of our place in the universe, neither boundlessly immense nor infinitesimally small. We occupy a middle ground, an average height, size, and lifespan that align with neither the vast cosmos nor the blink of any lifetimes of subatomic particles. Our existence falls somewhere between the Planck length and Planck time, the ultimate limit set by quantum physics. While we contemplate the cosmos and the fundamental events that occurred shortly after the Big Bang, scientists are venturing ever deeper into inner space. With ingenuity, funding, and dedication, we may unveil the mysteries hidden within the infinitesimal world of atoms and particles. The nano-world beneath our feet and under our fingernails may yet prove as captivating and astounding as the celestial marvels that grace the night sky.